Hello and welcome back to Bioclass Bytes. In this video, we are going to talk about categories of rocks and the rock cycle. Don't forget to subscribe to my channel and like and share this video. These are the unit and lesson titles for this video series. For Unit 2, Earth Materials and Processes, we have categories of rocks and the rock cycle, exogenic processes, plate tectonics, orogeny and hyperorogeny, volcanism and earthquake, and history of the Earth. In this video, we are going to focus on categories of rocks and the rock cycle. I recommend that you visit this website from geology.com. They have a lot of information about igneous, metamorphic, and sedimentary rocks. I also recommend that you visit Annenberg Learner. They have a lot of interactive websites about the rock cycle. I will provide the links in the description below. This diagram shows us the classification of rocks. So you have your igneous rocks, which are formed from the cooling of Earth's magma. And if the cooling happens within the Earth's surface, we call them intrusive igneous rocks. Examples are gabbro, diorite, granodiorite, and granite. If the cooling happens above the Earth's surface, we call them extrusive igneous rocks. Examples are basalt, andesite, dacite, and rhyolite. Sedimentary rocks are created by the compaction of sediments or eroded rock particles. And if the formation happens because of mechanical weathering, we call them clastic sedimentary rocks, such as conglomerate, breccia, and sandstone. If the compaction are results of biological processes or um, biological events, we call them biological sedimentary rocks, such as coal and chert. If the formation of the rocks happened because of chemical weathering and chemical processes, we call them chemical sedimentary rocks, such as limestone and dolostone. Metamorphic rocks are formed by the changes brought by pressure and temperature of the earth. So you have your foliated or the layered metamorphic rocks. So you have your slate, schist, and gneiss. Well, the non-foliated or non-layered metamorphic rocks are your quartzites and marble. Geologists divide rocks into three groups: igneous, sedimentary, and metamorphic rocks. So in this photo from northern Arizona, we can find igneous rocks. Okay, igneous rocks form when molten rock solidifies and at the surface. We call them extrusive igneous rocks, or if they solidifies beneath the surface, we call them intrusive igneous rocks. So we see here the lava flow, okay, coming from one of the craters. So since they solidified above the surface, we call them extrusive igneous rocks. Sedimentary rocks consist of particles derived from the weathering of other rocks. Okay, so we will learn more about weathering when we go to exogenic processes. So once those weathered particles are carried off to usually bodies of water, they lay on top of each other in different layers. Okay, they lay on top of each other. So this layering consists of durable sand-sized grains of the glassy mineral quartz that are cemented into a solid rock. So after years and years of compaction, they become solidified. So those grainy particles solidified to become sedimentary rocks. So this rock layer called the Navajo sandstone is prominent in southern Utah. So this part used to be underwater, but due to geological uplift, they are now part of the mountains. So they were brought up into the surface, and now we see the layering of those sedimentary rocks. Metamorphic rocks, okay, as seen here in known as the Vishnu schist, is exposed in the inner gorge of the Grand Canyon. So Grand Canyon, the formation is associated with the environments deep below the Earth's surface, where temperatures are high with forces and with the forces associated with mountain building processes, okay, that occurred as far back as Precambrian time. So metamorphic rocks are rocks that could be igneous or sedimentary rocks that have underwent transformation due to heat and pressure. And we will learn more about that as we go along. This is a simplified rock cycle from Annenberg Learner. I recommend that you visit that website. I will provide the link in the description below. So you see here the different events of the rock cycle, and the major rock types are present here: metamorphic rocks, igneous rocks, and sedimentary rocks. So we will learn more about this rock cycle as we go along. So the rock cycle is a useful way to illustrate how three of the main rocks change over time in a recurring sequence, and we call that the rock cycle. The concept of the rock cycle was attributed to James Hutton, an 18th century founder of modern geology. So this diagram is a more detailed depiction of the rock cycle. I understand it can be quite overwhelming for you, but actually as we go through our lesson on the different kinds of rocks and how they were formed, hopefully when we go back to this rock cycle, we can actually appreciate more the different processes involved. Okay, so this is actually divided into three parts. So here, the rock cycle tells us what's happening on the surface of the continents. So in this part, it tells us what's happening underneath the bodies of water, underneath the oceans. And here, it tells us what's happening in the Earth's mantle. So those will be the major parts of our discussion about the rock cycle. Okay, so one thing you have to remember about the rock cycle is that these events, these processes, these changes can actually take hundreds up to thousands, up to even millions of years over time. Okay, these are extremely slow processes. All of these are extremely slow events. So that's one thing you have to remember. So let's first start with the Earth's mantle, okay? So Earth's mantle is one of the layers of the Earth's geosphere. They're right below the lithosphere, asthenosphere. So here you have your molten rocks, and they can be pushed upward into the Earth's surface, and through magmatism, wherein they are converted into magma. And if that magma happens to cool, eventually as they are pushed upward, they become cooler. Um, if they happen to cool within and they are still within the Earth's surface, they become intrusive igneous rocks. But if they cooled after a volcanic eruption, if they cooled above the Earth's surface, they become what we call extrusive igneous rocks. Okay, so that's one pathway of magma from the mantle. Now, for example, if your extrusive rocks eventually undergo uplift, they are now found above the Earth's surface, they are now found on volcanoes or mountain, and they happen to undergo weathering and erosion, they could become what you call sediments. And sediments have two destinations. They could still remain and undergo processes while still on the earth, on the dry, on the land continents, or they can be transported back, they can be transported into the bodies of water, into oceans, wherein they will undergo a different pathway, okay? But one thing's for sure, extrusive rocks could, once they are lifted into the Earth's surface, can undergo weathering and erosion to become sediments. If those sediments are transported, deposited, and buried and underwent compaction and cementation while still on the Earth's continents, they will become sedimentary rocks. Okay, and so that's one destination, one transformation from igneous into sedimentary rocks. And if over hundreds and thousands and millions of years, if they are constantly buried, they underwent extreme heat and pressure, those sedimentary rocks could change and become metamorphic rocks. Okay, and if they're continuously pushed downwards, they could either undergo melting as they go nearer and nearer into the Earth's core and become the part of the magma, or they can be further subducted and become part of the Earth's mantle. So that's one pathway from magma to igneous rocks, broken into sediments, then turned into sedimentary rocks, turned into metamorphic rocks, back into the Earth's mantle. Okay? So that's one pathway. So another way wherein those igneous rocks become sediments is that they can be transported or carried into bodies of water wherein they are still sediments. They can now undergo compaction and cementation under bodies of water to become sedimentary rocks. So those sedimentary rocks can eventually still be buried deeper into the earth and become metamorphic rocks now. And you know what happens? They could melt and become magma or subducted and become part of the mantle. So those sedimentary rocks could also be subducted directly into the mantle, wherein they can be melted at the mid-ocean regions. So we will learn more about this in the upcoming videos to become part of the new magma, wherein they can either be expelled through underwater volcanoes, and if they cooled below the oceanic crust, they become now what we call a still intrusive igneous rocks, or if they erupted still under the bodies of water, but through volcanic underwater volcanoes, they can become extrusive igneous rocks. Okay, so one pathway is still to be subducted back into the mantle, and then they could undergo more changes from there. Okay, so what else? So again, so from magma to igneous rocks to weathering and erosion to become sediments to undergo this pathway, or from magma to igneous rocks and then undergo this pathway still to become sedimentary rocks back into mantle. So all of these events can take hundreds, thousands, and millions of years. Some of the magma can eventually become part of the volcano, and then eventually that volcano, after hundreds and thousands and millions of years, can be weathered and eroded, and then they become part of the new sediment, then turn into sedimentary rock, and so on and so forth. So maybe what we can see, the mountains that we can see right now used to be underwater. They just happen to undergo uplift and to become part of the continents. So all of those things take hundreds and thousands and billions of years to happen. For the purpose of discussion, we will use this simplified version of the rock cycle. Okay, so the arrows show us the paths that rocks can follow as they undergo changes. So you can find here the two types of igneous rocks: intrusive igneous rocks and extrusive igneous rocks. Then you can see here possible changes that will give rise to sediments and eventually become sedimentary rocks. Then you can see the different factors that can actually trigger changes for metamorphic rocks. So igneous rocks, the term igneous is derived from this word ignis, meaning fire. So coming from magma, they are very hot, of hot rocks, hot particles. So they are formed when magma or molten rock deep within the earth cools and hardens. Examples of those are your obsidian here, very beautiful black rock, and basalt, a fine-grained, grainy type of igneous rock. So when sometimes the magma cools inside the earth, we know what it's called, intrusive igneous rocks, or sometimes it erupts into the surface and from volcanoes, wherein they are now, from magma, they are now called lava. When lava cools very quickly, no crystals form and the rock looks shiny and glass-like. So as you can see here, obsidian is one good example. But when the gas bubbles are trapped during the cooling process, they leave behind tiny holes and spaces such as your basalt. So if you ever see obsidian or basalt, that could be a good reminder, a good reference that you are probably near a volcano. To help us understand better the difference between intrusive and extrusive igneous rocks, let's consider these illustrations. So, molten rock may crystallize at depth or underneath the surface or on top of the Earth's surface. So, molten rock that is found underneath the surface is called magma, but once it reaches the surface, we call it lava. Now, if so, that those molten rock underneath the surface that are part of the magma chamber cooled over time or crystallizes over time, they will become what we call intrusive igneous rocks. Okay, so that's their classification. But for example, if this magma happened to become part of volcanic eruption, or they happen to reach the surface and become part of the lava here, and they happen to cool or solidify over time, now we call them extrusive igneous rocks. So intrusive, underneath the earth, underneath the surface; extrusive igneous rocks, they cooled on top of Earth's surface. So igneous rocks are formed from the solidification of magma or molten rock materials, and we know that there are two types. So if the cooling happened below the Earth's surface, they are called intrusive igneous rocks. Okay, and the slow cooling that occurs allows large crystals to form, such as what you see here in granite. So there are crystals embedded within that rock. While extrusive igneous rocks they come from the eruption of the surface from the volcano, wherein they cool very quickly and they form very small crystals. So examples of that are your basalt, we've shown that a while ago, and here your pumice, okay? Now this shows us the type of igneous rocks and the location where they specifically form. So um, if an igneous rock has a glassy texture, just like this obsidian, it looks like a natural gas. It's usually formed when high silica-rich magmas solidify. Okay, so they solidify somewhere here quickly. Then for porphyritic texture type of igneous rocks is composed of two distinctly different crystal sizes, and they form somewhere here, just beneath the volcano's surface. Now, deep into the earth, when near the magma chamber, and then they just happen to crystallize, you have your phaneritic or coarse-grained texture igneous rocks. Okay. Now, vesicular texture like this one, and we can see them in pumice. Um, these are extrusive rocks. Okay, so they are now on the Earth's surface. Okay, they have these voids. Okay, that were left by gas bubbles. Okay, that escaped when as lava solidifies. So these voids here used to be um, formed by gas bubbles. Then you have your pyroclastic or fragmental texture types of igneous rocks. These are produced they used to be molten blobs that happen to cool down, right? They were ejected during the volcanic eruption, so here. And then aphanitic or fine-grained texture. So these are formed somewhere here on the volcano surface. These are composed of crystals that are too small for the individual minerals to be identified without using a microscope. So all of these are very interesting types of igneous rocks, and this is where they most probably were created. How do igneous rocks fit in the rock cycle? Okay, so igneous rocks that are considered intrusive, or they cooled or solidified underneath the Earth's surface, could undergo metamorphism, right, through heat and pressure, and turn into metamorphic rocks. Then eventually those metamorphic rocks could be pushed downward back into the magma chamber and undergo melting to become part of magma again, right? And then this is just one possible path for igneous rocks. So that magma will eventually crystallize and then they return as intrusive igneous rocks. Or if the igneous rocks happen to be part of the volcanic eruption and then they happen to reach the surface and become part of they become part of the Earth's surface, then eventually they could undergo weathering, erosion, and then transportation, then deposition of those sediments. So they will be weathered and eroded, carried on by exogenic processes to become sediments, or very small, finely grained rock particles. Now, those sediments could undergo lithification or compaction and cementation through pressure to turn into sedimentary rock. So you can see here the different layers of sedimentary rock. Now, those sedimentary rocks could continue and undergo uplift and continue the cycle of weathering and erosion, or they can be pushed downward to become part of the magma chamber again. So the next category of rocks is called sedimentary rocks, from the term sedimento, meaning settling. Okay, so these are types of rock that are formed by the deposition and cementation of that material at the Earth's surface and within bodies of water. So this is one thing you have to remember. Most sedimentary rocks are buried and compacted beneath bodies of water. So we have here examples of Middle Triassic marine sequence of siltstone and limestones. So as you can see, these are sedimentary rocks that are formed under bodies of water. If you're wondering why are they now part of this mountain or rock formation, it's because they underwent uplift. They were lifted underwater and now they are part of this mountain. Okay, it's quite hard to imagine right now But do not forget that all of these processes take place within millions and millions of years. This one is another good rock formation, steeply deeping sedimentary rock along Kalus Road in northern Iraq. So as you can see, if there's this lead layering here that you can find, that's actually a good indication that this used to be underwater, and these are actually sedimentary rock that underwent uplift. They're pushed up into the Earth's surface over thousands and millions of years. So sedimentation is the collective term for the processes that cause minerals to settle in place. Okay, so these particles, after undergoing erosion and weathering and erosion, accumulate into what we call sediments. So sedimentary rocks are deposited layer by layer, forming a structure called bedding. So these are good examples of bedding. As you can see, they are layered, piled on top of each other, and compacted over time. Based on the nature on how they were formed, sedimentary rocks are important records of what happened on Earth's geologic past. Okay, since sedimentary rocks are formed through compacting and cementing of those sediments, sometimes it's possible for living organisms to die and be preserved among these layers of the sedimentary rocks. Vertical changes also in the rock types as time goes by, as layers are added upon layers, represent environmental changes through time. So these are examples of those beddings and layering and compacting of sediments over millions and millions of years in Dunraven Bay along the coast of Wales. So sedimentary rocks are very important land features that show us the history of the Earth um, thousands and millions and billions of years ago. So sedimentary rocks are formed by accumulation of sediments, and they are classified based on the process that they underwent weathering. So those rocks that underwent, that eventually become sedimentary rocks that underwent mechanical weathering are called clastic sedimentary rocks, such as breccia here that you can see. They are products of mechanical weathering. Okay, so clastic means broken into pieces. So examples are sandstone, siltstone, and shale. All of those underwent mechanical weathering. Chemical sedimentary rocks are products of chemical processes such as precipitation of materials from solutions. Examples are salt, flint, dolomites, and limestones. Those are results of chemical weathering, creating chemical sedimentary rocks. Last type of sedimentary rocks are organic sedimentary rocks. So the term organic means they must have come from plant or animal remains or debris. So examples are your coal here, bituminous coal, dolites, and some limestones. So these are remains, hardened remains, settled and compacted remains of living organisms. Okay, so coal is one good example. So coal are actually remains of organisms. They are the bodies, remains of those organisms hundreds and thousands of years ago that have underwent compaction and eventually become melted because of the Earth's core. And now we harvest them and we use them for fuel. Now remember that these sedimentary rocks, okay, used to be underwater, okay? So they just underwent geological uplift. They were pushed upwards and they become now parts of mountain formations. But you can see several types of sedimentary rocks suggest the type of sediments that were formed during those periods in history. So they say that weak, poorly cemented shale, okay, okay, the ones that are found on this part of this formation, produces a gentler slope of weathered debris. So shale is actually very easy to be weathered, very easy to be broken down. So we do not see them anymore. But beds of resistant sandstone and limestone, as you can see here, they're still here. They're still solid and compact. They are made up of more resistant sediments. Okay. We see here another beautiful photos of sediments, okay, sediment formation, sedimentary rocks. Okay, this shows us the sedimentary strata or layers in Karijini National Park, Western Australia. So imagine each layer was formed thousands and hundreds of thousands and millions of years ago, and they are compacted and cemented and preserved, and then eventually underwent geological uplift um, so that we can see them today. Now, this is what I was talking to you about, the nature of sedimentary rocks to preserve remains of organisms. So it's quite rare, no, but it's possible for actual remains of organisms to be embedded on that on a particular layer of sedimentary rock. So imagine this used to be underwater, and perhaps this organism died during that period of time, and then it happened to be trapped and then compacted and cemented in that layer of sedimentary rock, and we just happened to discover it um, recently. Okay, so fossils that are stored in sedimentary rock could be the actual remain of an organism, or they could be impressions of dinosaur footprints, as you can see here. Okay. So, ito, note lang that when muddy sediments dry out, they shrink and create cracks. Okay? When sediment is turned into rock, the cracks are preserved. Okay? So it's possible that the cracking happened millions of years ago, and then it was layered again, but by this time a different type of sedimentary rock. So you can see the outline of the cracks preserved neatly in this image. These are more examples of beautifully preserved fossils. Okay, so we have different types of fossils. A petrified wood, okay, in Arizona. We see here the trilobite, okay, mold and cast. So this was the actual remains of the body, and then this was the um, or the mold that they were actually preserved with. And then you see here a fossil bee preserved as a thin carbon film between layers of sedimentary rock. These are impressions of fish from prehistoric time, and then this one is actually uh, cropolite, fossilized dung, okay, or excrement. And then we see here a spider trapped in amber. Okay, so these are excellent fossil records, and this one is a skeleton of a mammoth that they were able to dug from the La Brea tar pits. Okay, so here you can see them excavating from the tar pit. Okay, so scientists have been excavating from La Brea tar pits as far back as 1915. So so they say that the La Brea tar pit is a rich site of unaltered ice age organisms, and because of the tar here, they were able to be preserved perfectly, and we were able to excavate a lot from the tar pits. So where do the sedimentary rocks fit in the rock cycle? So remember that all of these layers used to be underwater. Okay, so they are found underwater. So the sediments were settled and compacted underwater, but due to geological uplift, they were exposed. So the movement of the plates underneath the Earth's surface pushed these underwater sedimentary rocks upward, and now they are now exposed. So we can see them now. We can see them like this. Okay, they are now exposed upward, and since they are exposed on Earth's surface, they are prone to weathering. Okay, prone to weathering and erosion. Okay, so they are broken. So the rock formations are broken into smaller sediments, and then they're transported by water or wind, okay, or other agents of erosion, and then they're eventually deposited again on bodies of water. Okay, so they undergo the same process. They are deposited. So the smaller sediments are or grain-like materials are compacted again and cemented again and buried deep into the under the bodies of water, eventually they become sedimentary rocks. So that's one possible cycle of sedimentary rocks. Or they could not be uplifted, or they were not uplifted or exposed on the Earth's surface, but further pushed downward, okay, closer and closer to the magma. So in which the sedimentary rocks will undergo metamorphism and turn into metamorphic rocks. And if it's still pushed downwards, it can merge with the magma chamber below, undergo melting, and then become part of the magma, in which they could now become igneous rocks, possibly in the future. So that's how sedimentary rocks fit in the rock cycle. Metamorphic rocks is derived from the terms meta, meaning change, morph, form. So these are rocks that have undergone change and form over hundreds and thousands and millions of years. So they have been modified by the following agents of metamorphism: heat, pressure, and chemical processes, as they are pushed deep below the Earth's surface. So they have, because of these factors, the minerals, the texture, and chemical compositions of rocks might have altered through time. So examples of those are your marble, non-foliated metamorphic rocks, and lapis lazuli. This is actually my favorite mineral, my favorite gem material. It's actually a metamorphic rock. So metamorphic rocks are classified into two, no? Based on their appearance, that gives us an idea on how much they've been changed by heat and pressure. So non-foliated, non-layered. There's no layering. Non-foliated metamorphic rocks, such as marble and quartzites, do not have layers. As you can see, they do not have layers here. Non-foliated um, rocks. Compare that to foliated or layered rocks. You can distinctly see the different layers of the rocks here. Okay, they are examples of them are gneiss, phyllite, schist, and slate. Gneiss and phyllite. They have layered or bonded appearance. They are produced by total compaction and layering over time. So they are constantly turned over. So they are turned over and over, just like folding clothes. So as you fold them, there's now two layers. If you fold another way, now there are four layers. So these rocks have undergone those processes, those folding over time. We can actually determine the type of metamorphic rock based on their appearance. That suggests us the type of temperature and pressure that they underwent through. So for letter A, we see here low-grade metamorphism. Okay, so that's commonly exhibited by shale transforming or metamorphing into slate. So as you can see here, they do not have that much layering. Okay, as previously discussed. Okay, they're not as foliated. Um, and it suggests that this is just a low-grade metamorphism because they were just exposed to low temperatures and pressures. Okay, so from shale, metamorphing into slate. Now, we have what we call high-grade metamorphism, as shown here. Um, Transformation of the parent rock granodiorite into a metamorphic rock, folded gneiss. Okay, as you can see here, we've seen that foliated metamorphic rocks. So it suggests that they have undergone high-grade metamorphism and they were exposed to high temperature and pressure underneath the Earth's surface. The temperature for this type of transformation is only possible when it occurs at high temperature, that's so high that the rocks are melting. Okay? The rocks can melt. So, what causes metamorphism in rocks? Number one is pressure. So, this includes the weight of the rocks deep within the earth. So, shear pressure from the faults can actually cause rocks to undergo metamorphosis. So, pressure, they're folded over and over, that creates those layers. So, the heat, since they are being pushed downwards and they become nearer and nearer to heat sources such as magma, geothermal heat, and friction, that's another way that rocks undergo metamorphosis. In hydrothermal solutions, the chemical activity that happens caused by water at high temperatures under oceans and seas cause rocks to dissolve, to transport dissolved materials and to catalyze chemical changes, creating further changes in the chemical composition of the rocks. So we see here an example of that folding I was talking about. So as you can see here, metamorphic rocks are also rated based on how much folding they have undergone through. So those that do not show much folding, much layering are said to be low-grade metamorphic rocks. But those rocks that have undergone a lot of folding are said to have high-grade or are said to be high-grade metamorphic rocks. So with increasing temperature and pressure, right, the metamorphic grade also increases. So this is one example I was talking a while ago. So these are still near the surface. They're being pushed downwards, but they do not have layers that much. It means that they haven't folded that much. But on this side, there are um, several rock formations above it, and they're slowly starting to deform in shape. So there's folding in this area. So now this is one type of foliated metamorphic rock. But here, as they go deeper and deeper, more folding, more squeezing, more compacting of the layers. Now you can see more layering in this rock, such as sheets. And then here in gneiss, more layering, more folding. They're constantly being squeezed from different areas. They're constantly undergoing heat, exposed to pressure and temperature. So they're showing this different layers. So this used to be one layer, one straight layer, but they're being squeezed. So they're now all squiggly like that. And if they keep on being pushed downward, the more squiggly the lines are until you form these different layers of metamorphic rocks. Where do metamorphic rocks fit in the rock cycle? Okay, as we've studied, um, metamorphic rocks could have started out as igneous rocks or sedimentary rocks that just underwent metamorphism after being exposed to agents of metamorphism such as heat, pressure, and hydrothermal solutions. So if those type of rocks have undergone metamorphism, they become metamorphic rocks, and those metamorphic rocks could undergo folding on itself after thousands and hundreds of thousands and millions of years. Sometimes they can be pushed downward, okay, deeper into the Earth's surface and undergo melting and become part of magma, okay, wherein the magma could now, has several paths to take. It could either become intrusive igneous rocks or be expelled, okay, out into the Earth's surface through volcanic eruptions, um, and become extrusive igneous rocks. Okay, so that's where metamorphic rocks fit in the rock cycle. So now that we've discussed the different processes of the categories of rock, let's go back to this diagram of the rock cycle. So let's review. So you have your mantle. Sometimes the molten rock from the mantle are pushed upward and they become magma. If the magma cools, while still remaining underneath the Earth's surface, we call them intrusive igneous rocks. But if they happen if the magma happen to form out into a volcano and the volcano erupts, then the lava turning into lava, and now they cool down to become extrusive igneous rocks. So sometimes those extrusive igneous rocks can undergo weathering and erosion to form sediments. Sediments have two fates. They can either undergo changes while still being maintained in the continents, or they can be transported into the bodies of water. So those sediments can be transported, deposited, buried, and compacted into your sedimentary rocks, wherein they can undergo heat, pressure, and deeper compaction to turn into metamorphic rocks. Those metamorphic rocks can be melted as they push downwards into the Earth's geosphere and become magma, or they can be subducted and become part of the Earth's mantle. Sediments that were transported into the bodies of water are still sediments, and they could undergo compaction and cementation to become sedimentary rocks, in which they can still be pushed through subduction deeper into the Earth's mantle to become part of that. Wherein underwater volcano could erupt and form magma, and when that magma cooled into lava, but it could still beneath the Earth's surface, we call that intrusive igneous rocks. But when they erupted and cooled outside the Earth's surface, but still underwater, we still call them extrusive igneous rocks. So another fate is for them to be subducted into the Earth's mantle. Okay, so intrusive igneous rocks can still undergo deep burial to become metamorphic rocks, or then sedimentary rocks can undergo burial to become metamorphic rocks, then so on and so on. So these are the possible fates of the different rocks of the Earth's surface. Now, people, do not forget, we've talked about this in the video Earth materials. Okay, I mean Earth structures. Do not forget that in terms of material, the Earth is considered a closed system. It means that all the rocks we see right now, those have been the same rocks that have undergone all these processes, hundreds, thousands, millions, and billions of years ago. So the rock that you're seeing right now, those are the same rocks that possibly they started out as sedimentary rocks, but now they are metamorphic rocks. The volcano that we see right now, those basalt, those obsidian, they are the same rocks that have undergone all these changes for hundreds and thousands of years. So in terms of material, we do not get rocks from outer space. We are considered a closed system. So all the rocks that we see right now, all those land formations, um, are the same rock formations that we've had since the Earth was formed. So they just underwent different processes of the rock cycle. So the main idea that I want to establish here is that rocks are continuously changing from one type to another as forces of the Earth bring them closer to the surface through uplift, or the forces of the Earth sink them back down to be part of the magma, or part of the mantle. So nothing is permanent. So the mountains that you see right now, they will not remain mountains forever. They could undergo weathering and erosion, wherein they could become sediments, or they can be pushed downward back into the mantle. And those that are found under those rocks, or those land that are found underneath bodies of water, they will not remain there. Hundreds and thousands and millions of years in the future, those sedimentary rocks could actually become part of the land formation. They can undergo uplift and become the future mountains and future volcanoes of the continents. So the elements that make up rocks are never created or destroyed. They are just continuously being recycled. Those are the same rocks that since the time of the dinosaurs, since the time before the dinosaurs, they are just undergoing this rock cycle. So the rock cycle hopefully helped you to see that the Earth is actually a giant rock recycling machine. The Earth, in terms of material, is considered a closed system. So we are just recycling the rock materials over and over and over. So here are some recommendations. This is from Fuse School. What is the rock cycle? I recommend that you watch this. I will provide the link in the description below. This is an interactive game. You can check this out from Annenberg Learner. Again, links in the description below. Still from Annenberg, rock cycle diagram. Kindly check this out. Link in the description below. Here again, try to complete the rock cycle. So I'll provide the link below. Then, so at this part, let's try to clarify some terms that you might be confused of. First would be rocks and minerals. So a rock is a naturally occurring aggregate, okay, or combination of materials and mineraloids. Rocks do not have a definite chemical composition. Mineral, on the other hand, is a natural occurring substance formed through geological process, and they have a characteristic chemical composition. So just to clarify, so rocks are aggregate, okay? They are made up of more than one material. Minerals are pure, they are only made up of the same substance. Rocks do not have crystals, they are not usually pretty, they do not have a definite shape, they have different colors, some may even contain fossils. In terms of usage, they are used in shelter and foundation. While minerals, on the other hand, they are made up of crystals. They are usually beautiful and pretty. They have a definite shape. The color is uniform. They do not have fossils because these are made up of chemical processes, and they are important in functions such as bone and tooth formation, blood coagulation, and muscle contraction from the human perspective. So let's see. So these are examples of rock specimen: diatomite, limestone, shale, flint, bituminous coal. So they're not really that pretty or colorful to look at. But if you look at minerals such as garnet, stalactite, vanadinite, azurite, so they're quite pretty. Okay, they are quite beautiful. They have these shapes to look at, and they're made up of the same minerals. Okay. they are made up of the same substance. So here in mudstone, you can have different types of crystals there or different types of minerals there. But here in vanadite, it's just made up of vandanite. Okay, garnet just made up of garnet. So minerals are actually quite pretty to look at. So that's one way to classify them. So another distinction I hope that you will be able to make is the difference between rocks and stones. So rocks is the hard material of the Earth's crust, okay? Normally exposed on the surface of the Earth and sometimes underlying the soil. So a stone, on the other hand, is a solid non-metallic mineral of which a rock is made. So it can be said that rocks constitute that stones constitute what is called a rock. So just to further distinguish, so rocks are large pieces of stone, while stones are that's quite difficult to carry, while stones are small pieces of rocks that can be carried. Rocks are immovable, needs much effort. Stones are movable, needs less effort. Rocks are made from other rocks through the rock cycle, so they can be igneous, sedimentary, or metamorphic, while stones are formed from rocks after it has been trimmed, dressed, or polished into tiny pieces through weathering and erosion. Rocks can be both hard and soft. Stones, on the other hand, are usually hard. Rocks are not used on construction industry, while stones are used in construction activities. So to further differentiate, so these are examples of rocks or rock formation. These are the Aphrodite rocks in Cyprus, Giant's Causeway in Northern Ireland, very beautiful. Then the Khao Tapu James Bond Island in Thailand. Okay, so these are examples of rocks and rock formation. Well, these are your typical stones. Okay, so pebbles, stones, you can find them on rivers. Okay, so yeah. Now, I recommend that you visit this website from BBC, Amazing Landscapes and Rock Formations of the World. I'll provide the link in the description below. Now, this may not be a reflective journal log, but you can actually ponder on this. So, according to the first law of thermodynamics, matter nor energy cannot be created nor destroyed, but can only be converted from one form to another. Einstein also said that the total amount of energy or matter in the universe is constant. So, how can we apply the first law of thermodynamics in the concept of the rock cycle? Okay? So, kindly think about that and try to explain. That ends our video. I hope you learned something new. Don't forget to subscribe to my channel and like and share this video. Till next time, goodbye.